Hello everyone, welcome to my channel. So today we'll discuss about Google Kickstart problem 2022 round H, a magical well of lilies. Here the problem statement says that you do have a magical well of L lilies. Okay. So and the number of lilies are greater than or equal to 1 or less than or equal to 10 power 5. Also you have a basket where you have coins and number of coins are always greater than number of lilies. For example, in if there's a well or magical well with 5 lilies, you have coins more than 6 or more. Okay, and if you toss one coin, okay, into this well, there are three conditions. Okay, so if you toss one coin you will get one lily, and if you toss four coins, the well notes down. Okay, it has a memory and it notes down. Okay, so how many lilies it has passed you before. Okay, and if you toss two coins, the well toss you back the number of noted lilies. Okay, it doesn't mean that if you toss like five times one coins, then suddenly if you toss two coins, if it doesn't store anything, then it won't toss you back. Okay, remember that. So always you first you have to notes the number of lilies, then you have to. So this will come in order 4 and 2. Okay. Now let us try to understand the logic. That time you will understand these three statements very clear. In the input sample, we have t number of test cases, and for every test case, we have number of lilies, only one integer. Okay, so L is equal to 5 here, L is equal to 20, and L is nothing but the number of lilies. So, and let us also copy these three main points, and these three the entire problem is depends on these 3 points. Okay, and for first case, L is equal to 5. No need of you wasting this 4, because when we toss 4 coins, well, it doesn't toss any lilies back to you. Okay, our main goal is to use as many lower coin as possible, because if we use 4 and 2 combination here, we already have 6 wasting, right, coins wasting. But for first case we can just use one coin each, 1 2 3 4 5. Okay, toss one coin 5 times, so we get output as 5. But for L is equal to 20, right, let us create a simple table to understand. Okay, so here I have 3 columns. One is that what the coins we toss, and the well tosses how many lilies, and what is the balance. Okay, balance lilies which are remaining in the well. Okay. First, we will toss one coin. Okay, so well will also toss one lily, and the balance is equal to 19. Then we toss one more coin. Well toss one more lily, and balance is 18. We repeat this one more time, and let us assume now. Let us like try to note down this so that we can make it optimal. Try to make optimal. Okay. This is not optimal solution. I'm just showing one example. Okay, so we toss 4 coins, and well doesn't toss any lilies here, but it is noted down like it tossed 3 lilies before, 1 2 and 3. Okay, and then after that it actually we can repeat this, like we can now ask the well to toss three lilies each using two coins. Okay, so we toss 2 coins, well tosses 3 lilies, and the balance is 17 minus 3 is equal to 14. Again we toss 2 coins, well tosses number of noted lilies, and balance is 11. We keep repeating this until we get low number, okay, which is 2. Now we cannot toss 2 coins, because if we toss 2 coins, well doesn't have 3 lilies, so it will not toss any lilies. So we have to toss only one coin. So we get one lily each, and the balance will be one lily here, and finally we have no lilies left in the well. Okay. And if we try to add this up, like it will become 19. So it's not the optimal solution. So this is just an example like how this works I showed you. To make it optimal, let us again consider the same thing, but let us instead of throwing 4 coins at the fourth time, let us consider let us get 5 lilies first, using one coins each. Then we will toss 4 coins. Okay, then we have the well, it doesn't toss any lilies, but it notice down that it tossed to 5 lilies before. Okay, so now we can use, now here we have 15 coins left, and if well notes 5 coins, so if we can toss only 2 coins 3 times, because every time when we toss 2 coins, it will toss 5 lilies each. To get, then we can get all these 15 remaining. So 15 minus 5 is equal to 10, then 5, then 0. Okay, so here the we tossed only 15 coins to get all the lilies. Okay, so that's why the answer here is 50. Okay, now you may have one question. Can't we use 4 again after some time and 2 again after some time? Can't we update this number? I mean, as if we have a large integer. Okay, so to understand this, we will have one big example. Okay, let's consider L is equal to 100 in our next example. For L is equal to 100, okay, again we create a same table. We tossing coins and well tossing lilies and the balance. Okay, first we use one coin, well tosses one lily and balance is 99, and again we repeat this. Okay, so 5 times. Okay, and I'm trying to show the optimal solution only. Okay, so now after 5 times you toss 4 coins, then well tosses 0 lilies and balance is sorry, well doesn't toss any lilies, that's why balance remains same. 95 minus 0 is equal to 95. Okay, but it notes down like 5, number 5. So now you can toss 2 lilies, so sorry, 2 coins, then well tosses 5 lilies, balance is 90, and let's keep doing this only for some time. Okay, so after doing this like 4 times, okay, now well already tossed 1 2 3 4 5 into 4 is 20 and 20 25. So now here the well notes down 25 lilies it is already tossed. Okay, it will count this also, so everything will count. Okay, remember that. So after this, now if we toss 2 coins, we get 25 lilies. So from 75 we get a balance 50, and we can do this again. Toss 2 coins, we get 25 lilies and the balance is 25, and doing it last time we get balance 0. So if we add up all these numbers, we get sum is equal to 27. This is the optimal solution. You can try to do on your own, like some other combinations and all, but you will not get like least sum. Least sum is 27. So here if you observe, we use this 4 and 2 combination 2 times. Okay, so we can use it multiple times also as we progress, because at the end we need an optimal solution. Okay, so now we will in the next slide we'll try to understand how we can create a logic for this. First, let us define an output variable which contains the number of coins required. Okay, to get one lily, we can use 1 coin. To get 2 lilies, we can use 1 coin 2 times. To get 10 power 5 lilies, we can use 10 power 5 coins. To get 10 power 5 lilies, we can use 10 power 5 coins one by one. Okay, that is the initial state of the output, and this one will loop through and keep on updating and updating the value. Okay, so for that, first we will consider let's imagine that we have L, number of lilies. Okay, at ith point, okay, we have two choices. We can actually use 4 coins to note down the number of lilies which we actually used, or get uh, we can continue with the I plus 1. Okay, so that is what we have. So we have two choices: either just double it, 2i 3i 4i, just using 4 coins and then 2 coins each, or we can just go with the normal option. So in code what we need to do, we have to do both and we have to compare like which is minimum, and accordingly we have to update that value in the corresponding index. Okay, so that's what we have to do. So first, outer loop should be like from 1 to L, and inner loop should be from whatever given I position. Okay, for every I position we are looping through that index, and we are going I to from I till L. Okay, with I step. Let me just show you in the code. Okay, first this is the outer loop, and in the outer loop we are updating whether I mean, for example, here this doesn't make sense at the beginning, because if you see here, output of I plus 1 is 5, and 5 is whether less than, I mean, minimum we are picking up 4 plus 1 or 5. But I think when you check the second loop you'll understand. First we'll define temporary variable. Let's imagine that at ith position we are tossing 4 coins. Okay, and then we are looping uh, from that particular point, 2i 3i 4i till 10 power 5. Okay, and we are tossing to get 2 power I, we are tossing 10 plus 2, right? 2 coins extra we are tossing. That's by using temp variable plus 2, and we are checking whether this 2i or I plus 1, which is minimum. Existing is I plus 1, which we have already have in the list, or 2i, which is minimum, and we are updating the value of output array. Okay, that's what we're doing. And then once we do that, we'll go back to the main loop, and now we have here new value actually. Okay, output of I plus 1 or output of I. So accordingly it will check which is minimum, it will update. Okay, so that's why we are now I think this point is clear now, because we already checked this point. So it will this both will update the output array. Okay, so now let us check the Python code for this. In Python code, we first define L is equal to 10 power 5 initially, and then we are using a list from 0 to L plus 1. And why L plus 1? Because I'm using the next index. And why 0? Because, I mean, anyway, 0 doesn't make uh, any issues. It's just one value, extra value that in the list. Okay, but if you don't want that, you can just use 1 to range from 1 to till the last, and you can update here the plus 1 answer. Okay, and here the this output of I plus 1 or answer of I plus 1 is nothing but same thing we are doing here. Okay, the previous one plus 1 or the existing one, and that existing will keep on updating in this loop. Okay, so here we are tossing 4 coins, here tossing 2 coins, and we are doing the minimum here also, and output also, outside also we are doing minimum, and we are keep on updating this existing list. Okay, and here in these two lines, line 10 and line 11, we have time complexity just to O of 1, but time complexity for this is nothing but the maximum L, which is nothing 10 power 5. So 10 power 5 log int multiplied by log n, because we are iterating through ith index. I hope this is clear now. So if you have any doubts, you can ask me in the comment section. So thank you very much.